Okay, so today we've been talking about the Pythagorean theorem and we learned how to derive the formula for it, and now that we've been practicing with it a little bit, I thought it'd be fun to see how we can apply this outside of the classroom to a real life example. So for this video, what we're going to be doing is applying the Pythagorean theorem in baseball. So I'll start us off with a little clip here so you can see what we're going to be looking at.
Beckham goes after the first pitch. Donaldson steps on third across the diamond. Another double play.
Okay, so that went pretty quick. We'll go over it again in slow motion so that you guys can see what we're looking for here.
Beckham goes after the first pitch.
So it goes to the third base, they touch third, and they throw it straight across the diamond over to first base. So what we're going to be doing for this example is asking, how far did Donaldson have to throw to get Biagini out at first place for the double play? So we want to know how far that ball traveled when he threw it. So first let's just look at the setup of a baseball diamond. So what we know is that we have home plate where the runner starts, then they obviously go first, second, third, and all the way back to home. And what we can see here is that it clearly makes a square because we know that the distance between each of the bases is going to be equal, and we also know that these are going to be right angles. And so by definition, this is going to be a square. And we actually know the standard distance, so like on a professional field like this, it's going to be 90 feet between each of the bases. So that value is really going to come in handy in just a moment when we start to solve for the distance. So here's what happens. The ball started at home plate. It was hit to third base where the third baseman caught it, and then he threw it across the diamond to first base. So this is going to be the hypotenuse of our triangle, the distance from third to first. And so we've already been given the length of the two legs of our triangle, which is 90 feet, because that's how far it is from base to base. And basically all we need to find out is, using the Pythagorean theorem, what the hypotenuse of this triangle is going to be. And I know we've been working on this a lot today, but just to recall, formula for the Pythagorean theorem is a squared plus b squared equals c squared. That's where a and b are both legs of a triangle, and c is going to be the longest leg, which is the hypotenuse. So here we've got our whole setup just to review it for everybody. So our a is going to be 90 feet, our b is going to be 90 feet, and c is what we're solving for here. So I'm going to jump over to GeoGebra. Okay, so here you can see that we've drawn out the baseball diamond. Essentially, we have home, first, second, and third, all spaced 90 units out. And so what we can do here is we can take the polygon tool and we can actually draw a triangle that traces the line of the baseball. So it started at home, it went to third base, it was thrown over to first, and then we just go back to home to complete our triangle. And then GeoGebra does all these calculations for us, which is really great. And we just look for the value labeled home in lowercase letters because that's across from home plate. And we can see right here that that is 127.28 is the distance for that line segment. So let's go back to our slide and check and see if that works with our math. So basically all we did is we plugged in the values. First, you always rewrite your formula, is always the first step to solving any problem. And then we know a is going to be 90 and b is also going to be 90. And we just solve for 90 squared plus 90 squared, and that's something you'd probably use a calculator for. You can also use the calculator on GeoGebra. And you get that 16,200 equals c squared. And to get rid of this little squared, we just have to take the square root of both sides, and you end up with 127.28, which is what GeoGebra calculated was the hypotenuse of our triangle. So the solution to our problem is that the distance from third base to first base is 127.28 feet. And here's that play again if you guys want to see how quickly he can throw almost 130 feet.
Beckham goes after the first pitch. Donaldson steps on third across the diamond. Another double play.
And that's all for this video clip. Thanks guys for watching.